It's a very good morning, students. We started our second year and electric charges and field. Okay. In this, we have discussed some electrification in the last class. Electrification is nothing but giving the charge to a body. Giving a charge to a body is called as electrification. Got it here? So we can give a charge to a body. Three methods we have discussed. One is by friction, and the one is by conduction, and the one is by induction. Correct? Induction. Here we'll have a very good important bit here. For theory also we'll have the 1 mark question like this, 2 marks question, and the question will be: is the repulsion or attraction is a sure test for the knowing the charge of a body? We can say repulsion is a sure test. Means, try to understand this one clearly. Try to understand very clearly. Be concentrated, then we can understand very easily here. Means we have a body here. Either this body is a positive charge or negative charge body or neutral body, we don't know here. Understood here? Got it? Either I am having a body. Is this body is a positive charged body or a negative charged body or neutral charged body? We don't know. We have to check it. How can you identify the charge of a body? I'll tell you here. Try to understand this very carefully. If it is a positive charge, I don't know what is this charge. Okay, I am bringing a positive charged rod here. Correct? Positive charged body. Okay, now what the force is going to be acted between these two? Repulsive force, right? Repulsive force. Correct? Repulsive force. So this repulsive force between these two charges, okay, repulsive force is going to be acted. If it is a positive charge, the same positive rod I am taking here. If it is a negative charged body, what happens? Some attraction is going to be takes place. Correct? Attraction is going to be takes place. If this body is a neutral charged body, what is the meaning of neutral charge here? Having the same number of positive charge carriers and same number of negative charge carriers, means it is having the both positive charges and negative charges. Correct? It is having both positive charges and negative charges. When you bring a positive charge here, when you bring a positive charge to this, what happens here? This all negative charge comes to this end, correct? And this will become this side will get a positive charge. Okay, now in these situations, these two situations will have the attractive force here. Attractive force, correct? Attractive force. What is it here? Attractive. But here we will have the repulsive force. If you don't know the charge of this one, if you don't know the charge of this body, okay, when you are keeping it rod here, positive rod, you bring the positive rod to this body. If it is attracting, let's consider. I understand here. This is a neutral, some positive charged body, and I am bringing a positive charge. What is the force acting here? Repulsive force. If it is a negative charged body, what happens here? Attractive force. If it is a neutral charged body here, attractive force takes place. Correct? Attractive force takes place. Right now? So now, if it is here in these two situations, attraction is taking place. Right? Means if the body is attractive, means it may be a negative charged body or it may be a neutral charged body, right? If a body is attracted, means it may be a negative charged body or it may be a neutral charged body, we can say. Correct? Or if it is repulsion, means 100% I can say this is a positive charged body only. Understand? When you don't know the charges of these bodies, okay, you bring a positive charge to this here. You bring a positive charge to this here. We don't know which charge it is. If it is attracting, if this body is attracted by this may be a negative charged body or it may be a neutral charged body. If it is repelling means, what can I say? This is 100% positive charged body. Here I can confirm the charge of the body. Whereas here I cannot confirm the charge of the body. Correct? So repulsion is the best test of identifying the charge of a body. Understood here? Okay, na? Okay, we'll get one of the application, good application here. Okay, we'll see it again like that. Now, we have started our charges, okay, giving a charge to a body. What is charge? It's a polarity which we have seen. Charge is additive property. Additive property means here we can charge is a scalar quantity here. Charge is a scalar quantity. We can add it easily here. Okay. Directly we can add plus 5 coulomb, plus 1 coulomb, 6 coulomb, minus 6 coulomb, minus 2 coulomb, plus 3 coulomb. Combined, add them here. What is the total charge? Total charge becomes here 1 coulomb. 1 plus 1. Correct? Why? Because 5 plus 1, 6, minus 6, 0, minus 2 plus 3. Totally becomes 1. So we can add its additive property here. Blindly we can add because the charge is not having any direction, scalar quantity. Negative and positive represents the polarity here. Either it was having the electrons or protons it represents, right now. And next one very important, that is charge is quantized. Charge is quantized. The charge of any body will be integral multiples of electron charge. Integral multiples of the electron charge. Electron is an elementary particle here. That is a further cannot be divided. Elementary particle means the smallest here. Smallest in sense, especially why we are calling as elementary, because it cannot further divided. If you take an atom, atom is a combination of a nucleus and electrons here. Nucleus is a combination of protons and neutrons here. Right now, the molecule is a combination of atoms, but the electron is not like that. Electron cannot be further divided. It is individually formed. So it is an elementary particle. The charge of electron is E. E we know here 1.6 into how much? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb here. Charge of the electron is. And charge of any body will be in integral multiples of n. Integral multiples of charge n means, what's the meaning of this? The charge of any body may be 2e, 3e, like 4e, like this here. 4e, maybe 100e, 1000e, something like this, 100e, like this here. But the charge of any body cannot exist in fractions. In sense, 3 by 2e, not possible here. This is not possible at all. Understood here? N is an integer. N is an integer. 1, 2, 3, 4, 5, so on, so on, so here. Okay? But the fractions cannot exist. A very important point. Charge cannot exist in fractions of electron charge. Fractions of electron charge. Understood? Sorry, your charge of electrons is 1.6. So this is a fraction. Now that your fraction of these electrons, I'm saying, okay? 1.5 E is not possible. 1000.1, 100.1 E is not possible here. So these type of charges are not possible. 100% the charge of any body will be integral multiples of electron charge. Integral multiple of electron charge here 100%. Okay now? So the charge of any body may be positive or negative. It depends on the polarity. Correct? Charge may be positive charge or charge may be negative charge. It depends on the polarity. If the body is having, if the atom is having the full more number of electrons, then it is a negative charge. If the body is having the less number of electrons and having the more number of protons, then it's a positive charge in body right now. So the charge of any body may be positive or negative. It's a polarity we can say right now. And charge of any body will be an integral multiples of. It cannot exist in fractions. Are very important. Okay, na? This is charge is said to be quantized. Quantized means charge Q is equal to Ne. Understood? Q is equal to Ne. Let's consider here now. We can identify the charge number of electrons in a body. Let's consider our body. A body is having a charge of 1 coulomb. 1 coulomb charge means Q is equal to 1 he has given. Q is equal to 1. I'll write as capital or anything, ignore it. Okay, na? So, how many number of electrons are there in this 1 coulomb of charge? In 1 coulomb of charge, how many number of electrons are there? Simply from here, Q is equal to Ne. Correct? What is Q? 1. N. E. What is E? 1.6 into 10 power minus 19. So you will get N value as 1 by 1.6 into 10 power 19. Correct? What is this 1 by 1.6 means? What can I write here? 0.625, I think so. Correct? 0.625 into 10 power 19. These many number of electrons are there. Okay, na? 0.10. How many will get? 10. 1. 10 means 16 goes in 10. 80, 96, correct? Okay. 0.625 into 10 power 9. Number of electrons are present in this 1 coulomb of charge. So 0. How size? Okay, you can write it. What happens? 625 into 10 power 19. Number of 16 you get. So these many electrons are present. In 1 coulomb of charge, in any body, if you know the charger, we can identify how many electrons are there or how many protons are there. If it is a negative charged body, electrons are. If it is a positive charged body, protons are. Okay, na? Charge is said to be quantized, and charge is a conserved. Conserved means charge cannot be created, not destroyed. Okay, it can be transferred from one body to another body. Right now, it's a form of energy. It's a form of energy. Okay, this is about the story of this charge here. Now, what we are going to see from now class will be almost same as a gravitation which we discussed here. Okay. Once you go through the gravitation once again when we are discussing this, revise that one also, it will be better to you. Okay. As M1, M2 are the two masses. Have you seen that? What is the gravitational force between the two masses M1, M2 separated by distance R? The force of attraction, this force is gravitational force, is always attract to G M1 M2 by R square. Correct? Na? G M1 M2 by R square. Here G is a gravitational constant. 6.625 10 power minus 11 Newton per Newton meter square per kg square. Correct? Na? So that's we get a G value. And gravitational force doesn't depends on the medium present between the two bodies. It doesn't depends on the medium present between the two bodies. Understood? Here? It doesn't depends on the medium present between the two bodies. Now, I'm going to see this same force will have Newton's law of gravity there. Here, Coulomb's inverse square law. What is it? Coulomb's inverse square law. If two charges Q1, Q2, separated by charges, separated by a distance, separated by some distance, let's consider. Q1, Q2 are the two charges separated by some distance. The force between these two charges, will be directly proportional to product of their charges and inversely proportional to square of the distance between them. Means we can write the force is directly proportional to Q1, Q2 by R square here. Q1, Q2 by R square. Correct? Is equal to means what we have to do? Tell me here. We can write a constant. The constant here is 1 by 4 pi epsilon naught here. What is it? 1 by 4 pi epsilon naught. Understood here? 1 by 4 pi epsilon naught. Okay, na? So what is the search again? Q1, Q2 are the charges here. R is the distance between the two charges. Point size charges. We are discussing about the point size charges. Okay? Fine. This is 1 by 4 pi epsilon. What is this 1 by 4? It's a constant. Its value, remember that point here. 4 pi, 1 by 4 pi epsilon value is 9 into 10 power 9 here. 9 into 10 power 9. You can write the units also. Newton meter square per coulomb square. Understood here? You bring this total to left side. Force into R square. Newton meter square per coulomb square. 9 into 10 power 9 Newton meter square per coulomb square. This is the constant here. I'll tell you what are this. 1 by 4 pi. Pi value know here. 22 by 7. Okay. What is epsilon naught? Epsilon naught is the permittivity of the free space or air. Permittivity of the free space or air. Understood here? Epsilon naught is the permittivity of the free space or air. Understood here? Means this term represents the medium, right? This term, this epsilon naught represents the medium. Permittivity of the medium present between the two charges, right? Means this force depends on the medium. This force depends on the medium. Here where I am the epsilon naught. What is epsilon naught? It's a permittivity of the medium. From medium to medium means air medium, water medium, glass medium, solid medium, something, mercury medium, some other. They will have some medium value, permittivity. Means this force depends on the permittivity. This force depends on the medium. Understood here? This force depends on the medium. Got my point here? This force depends on the medium. What about the gravitational force? F is equal, we are getting here G M1 M2 by R square. Correct? In gravitation, distance between them is R. Masses means force depends on the masses and distance only. What about G? G value is a constant. Universal gravitational constant. Correct? 6.6 in 10 power minus 11. Correct? So means this gravitational force in the formula of this one, no term represents the medium. That's why this gravitational force doesn't depend on the medium. In the formula of this one, it doesn't depend on the medium. But here, this electrostatic force, we call this one as electrostatic force. Electrostatic force means charges are at rest. Electro means electric charges. Okay? At rest. Rest. They are at rest. Electrostatic force, we take this one as okay, na? So this is the electrostatic force here. Got it? I'll tell you here one more. If these two are like charges, positive, positive, what is this force? What is the force you get here? 1 by 4 pi epsilon naught. Correct? Q1 Q2 by R square. If this is positive, plus Q1. This is also positive, plus Q2. Plus into plus, how much you will get here? Plus. The force becomes positive. Correct? Let's consider if these two charges are negative, take it. Q1 minus Q2. Product of charges here. Force is directly proportional to product of charges. Force is directly proportional to product of charges. Right now? Force is directly proportional to product of charges. Now check it here. Minus Q1 minus Q2. Minus Q1 minus Q2. Minus or minus plus. Again you are getting this one as Q1 Q2. So again the force becomes positive only. Very important point here this is. Force is positive means it's a repulsive force. Remember the point. Force is positive means repulsive. Let's take the two charges of different polarity. One is negative and the one is positive. Minus Q1 into Q2. Minus into plus. Minus you get. This force becomes negative here. This force becomes negative. So this force is attractive. If the force is positive, it's a repulsive force. If the force is negative, it's an attractive force, we can say. Or we can simply say that the two like charges will repel, unlike charges will attract. Understood here? Like charges will repel, unlike charges will repel here. Unlike charges will attract, sorry. Okay, na? Unlike charges. If the force is, or we can say force is negative means attractive, force is positive means repulsive, we can say. And the vector form of this force is a vector quantity here. Correct? Na? The vector form of the force, as we have written there, have remembered, G m1 m2 by r square into r cap. Why we are multiplying with r cap? R cap is unit vector which gives the direction. In the same way here we can say 1 by 4 pi epsilon naught q1 q2 by r square into r cap. Why I am writing here r cap? R cap is unit vector. If I multiply with a unit vector, the magnitude of the force doesn't change it. But r cap gives a direction. I am writing here 2I cap. What is the meaning of this one? 2 meters towards x-axis. Or we will write a 5j cap. What does it represent? 5 meters along y-axis. Correct? So in the same way, this force acts along the direction of the distance. Means this force acts along this direction. So it's a central force, we can say. What is it? Central force. So the vector form of this force again we can write as 1 by 4 pi epsilon naught q1 q2. How to write the unit vector? R bar. R cap is called R bar by mod R, right? R bar by mod R. R bar by mod R is a vector notation we can write here. Okay, na? And I'll tell you one more point here. The force acting on 1 by 2. What is the force acting on 1 by 2? On 1. It's a repulsive force. Remember, very important. I'll write right here. Two charges I'm taking here. Q1 and Q2 are the two charges here. Okay. Force on 1 by 2. See here. Force on 1 by 2 is equal to 1 by 4 pi epsilon naught. Q1, Q2 by R square. Okay. In which direction? Force on 1 by 2. It's a repulsive force, right? Force on 1. Be careful there. On Q1, Q2 will apply force in this direction. Correct? On Q1, Q2 will apply force in opposite direction. Correct? Repulsion. Repulsion means away in this direction. Force on 1 by 2. Force on 1 by 2. Second one, we will apply force on 1 in which direction? Repulsive force means moving away, right? Pushes, sorry. Force on 2 by 1 will be. This is negative, right? I am writing as minus I cap. Let's consider minus I cap. Right? Negative x-axis. What about this? Force on 2 by 1. Force on 2 by 1. 1 will apply force on 2 in which direction? In this direction. F21 is 1 by 4 pi epsilon naught q1 q2 by r square. What's the direction of the force here? Direction of the force is in this direction. This is along F21 I can say here. Correct? In positive x-axis direction. So I taken as I cap. Correct? So if you observe here, these two are equal in magnitude but opposite in direction. but opposite in a direction. See, magnitude is multiplied by 4 pi current by r square. Opposite in magnitude. So this is the force here which present between the two charges if they are separated by in a free space. In a free space. Epsilon naught is a permitted here. We can calculate this value also. We forgot here. From here, what is epsilon naught? Tell me. Epsilon naught, what is epsilon naught here? Permitted of the free space. From here, epsilon naught means I can write this one as 4 pi into 9 into 10 power 9, right? Correct? Calculate this one, you'll get around 1 second. 8.85 into 10 power minus 12, I think so, maximum 1 second, okay? Once make a calculation, do it, okay? Epsilon naught is the permit of the medium, so the electrostatic force depends on the medium, whereas the gravitational force doesn't depends on the medium, right now? Right? Basing on this, you can take do some problems and try to do, okay? Try to take the materials as early as possible, yes. Okay, na? Bye.